For this video, we're going to be discussing graphing inequalities. So let's first start by defining just exactly what an inequality is. An inequality is a math statement showing that one quantity is bigger or smaller than another. If we think back to equations when we had something like x equals 5, what we're saying is that x and 5 are equal, they mean the same thing. When we're talking about inequalities, we're saying that these are not equal to each other. In fact, one is bigger than the other. So one way I can write that is I can say x, I've got this inequality here, and this inequality symbol is the greater than symbol. So when we see this, we're saying x is greater than 8, or x is bigger than 8. For example, we could use 9 for x because 9 is bigger than 8. Or we could use 11 for x because 11 is bigger than 8. We couldn't use 7 because 7 isn't bigger than 8. If we think about this, our other symbol is the less than symbol. If I'm saying x is greater than 8, I can kind of reverse this and I can say 8 is less than x. And these two mean the exact same thing. So we think we can kind of flip them, but the sign has to flip with them. So this is the greater than symbol. We're saying x is greater than 8. Over here we have the less than symbol. We're saying b is less than 5. So we could say like 3 is less than 5, 2 is less than 5, -1 is less than 5, -17 is less than 5. B can be any number as long as it is smaller than 5. Now down here we have the greater than or equal to and the less than or equal to symbol. So here we're saying 9 is greater than or equal to g. So if we think about that, what kind of numbers could be going for g? Well, I could put in 9 because 9 is equal to 9, so that works. If I think I'm trying to say 9 is bigger than whatever this number is, I could put 8 there. 9 is bigger than 8. I could put 0 there. 9 is bigger than 0. I couldn't put 10 there because 9 is not bigger than 10, so that does not work. All right, so that's the greater than or equal to symbol. And similarly, we have the less than or equal to symbol, saying m is less than or equal to 7. So m could be like 2, or 6, -23. Because we have the equal to symbol, it could also be 7. So the difference here is this cannot be 5, this cannot be 8, but this can be 9, and this can be 7 because of the equal to symbols. So if I'm taking a look at these, I want to figure out what are some solutions that I could put in for x. What are some numbers that I can put in here that will make this true? So it's one number I could put in here. If I read this, this says x is greater than 7. Greater than meaning bigger, so I could say, well, what number could go here? It needs to be something bigger than 7. I could say, well, that could be 8. 8's bigger than 7. It could be 13. 13 is bigger than 7. It could be 207. That's bigger than 7. Can it be 7? Is 7 bigger than 7? Is a number bigger than itself? No, it's not. So it cannot be 7. Could it be 6? Is this true? Is 6 bigger than 7? No, it is not. So those are not. But these right here, these are numbers that all could fit in for x because they are all bigger than 7. Similarly, let's look over here. We're saying 4 is less than or equal to v. 4 less than or equal to v. And we want to think of what are some numbers that we could put in for that. Well, could it be 4? Well, sure it could be. We've got this equal to symbol here that says that this side can equal this side. So 4 works. Could it be 5? Well, it says less than or equal to. 4 is less than 5, so that one works. Could it be 3? Well, 4 is less than or equal to 3. Well, 4 is bigger than 3, so it's not the less than, and it doesn't equal 3, so no, it can't be this. So this is how we kind of discern some of the solutions to an inequality. So here's example 1. Example 1 says, list 3 solutions to the inequality 9 is less than x. So we're trying to put some numbers in here that 9 is less than. So what's one number we could think of? What's the smallest number we could think of that could go in here? Well, it says 9 is smaller than something. Well, let's say the easiest one is 9 is smaller than 10. That works. If 9 is smaller than 10, what's another number? Well, what's a number that 10 is smaller than? 9's smaller than 11, so that works. And then let's try an even crazier one. What's another number that's bigger than 9? How about 2,142? That's a lot bigger than 9, and so that follows what we see here. 9 is smaller than 2,142. So there are 3 solutions to this inequality. Here's a question, could it be 9? Is 9 smaller than 9? Well, no, a number is not smaller than itself, so 9 is not a solution. So now we're going to talk about graphing. So to graph a solved inequality, we need to look at the solution. We're going to place a circle on the number line at the value listed in the inequality. And if we have just a greater than or a less than symbol, it's going to be an open circle. And if it's a greater than or equal to or less than or equal to symbol, it's going to be a closed circle. And then we're going to locate several solutions to determine which way we should shade. So we look here. 3 is less than or equal to x. So I'm going to put 0 on here. I always put 0 on my number line so I'm able to locate where everything is. I'm always going to put my circle at this number, at the number that's in the inequality. So say 3 is over here. Now it's less than or equal to, so that means we get a closed circle. And the reason it's a closed circle is because we're saying that 3 is a solution. You need to be careful. Your circle needs to be on the line. We don't want to see any of this circle above the line somewhere stuff. No, circle needs to be on the line. And then it says we need to locate several solutions on the line to determine which way to shade. We need to color in one direction here. And if we look, I listed some solutions here. 4 is a solution, 5 is a solution, so is 6. So I need to think on what side of 3 are 4, 5, and 6? Well, you know that on a number line, bigger numbers are to the right, smaller numbers are to the left. So there's 4, there's 5, there's 6. Now that I see those points on there, that's the way that I'm going to color in. Please make sure that when you color in, you go all the way to the end of the line and that you are actually graphing on the line. Once again, none of this stuff. I don't want to see any lines above it. It is on the number line. Now, the reason that we're shading in is because we're saying that every point past 3 to the right here, every point bigger than 3 is a solution. This line is being made up of a bunch of individual little points, and no matter where I pick, like say right here, well, who knows what number that is, but that's in the solution. Or right here, that's also. Or like 5.5, or 4.2, or like 3.001. Those are all solutions to my inequality, and I shaded in to show that. So let's look at an example of this. It says, graph the inequality b is greater than or equal to 2. So I'd like you to pause the video right now and try this one on your notes, and then start it back up once you've tried it. All right, so now that you've tried this, let's graph this inequality. I always want to put 0 on here. And then I know my circle is going to go at the number listed in the inequality, that's 2. Because I've got this equal to bar, that's saying 2 is in the solution, so it's a closed circle. And now I need to determine which way I'm going to color in. So I need to think here. It says b is greater than 2. Greater than or equal to 2. So we know 2 is in the solution, but we need to think of some other ones. So what's one number I could put in here that is bigger than 2? Well, easy one. 3 is bigger than 2. 3 is here. Let's see, what else could I put in there? 7, that's bigger than 2. So we'll put 7 there. And how about 10? 10 is also bigger than 2. That'd be over here somewhere. There's 10. So I look at my 3 points, and all 3 points are to the right of my circle, so that's the way that I'm going to shade in. Now when you're graphing, you should realize that all 3 of your points that you're picking out as solutions should be on the same side of the circle, and if they're not, it's because you did something wrong. So this is what our graph looks like. Closed circle at 2, shaded to the left, or the right. Let's take a look at another example. Example 3 says, graph the inequality -5 is greater than m. Well, put 0 on here. We know that our circle is going to go at -5. There's no equal to sign, saying -5 is not part of the solution, so that's going to be an open circle. And now I need to think of what way I should shade. So it's saying -5 is bigger than whatever number I put here. What number is -5 bigger than? -5 is bigger than -6. So negative 6 is going to be in the solution. Negative 5 is also bigger than negative 5.5. That's like right halfway between negative 5 and negative 6. Negative 5 is also bigger than negative 8. So that's going to go right here, negative 8. And so my solution are all to the left, so that's the way that I'm going to shade in. And I want to show you this. We can think of our shading in as just making all these tiny little dots showing all of the solutions to this inequality. And those tiny dots all form this solid line pointing to the left. So this is what our graph should look like. So I'm going to leave you with a try it problem that says, which of the graph below shows the solution to 8 is less than x? So go through here and figure out which one of these shows the correct graph of this inequality.